This is the second video for section 13-2, and this one will be on dividing rational expressions. So before we even look at the rational expressions, let's just talk about reminding you on how you would divide fractions. If you remember, when you have a fraction divided by a fraction, we would keep the first fraction the same, change division to multiplication, and then do the reciprocal, which we also commonly said as flip. So keep, change, flip was what you should remember. Then from here, you can do one of two things. You can go ahead and cancel like terms. So you could do that 4 divided by 2 leaves you with a 2 here and a 1 here, and then multiply straight across so that your answer comes out to be 2/3. Or if you didn't see that, then you can multiply just straight across and you end up with 4/6, which reduces to 2/3. So remember that dividing rational expressions is just like dividing fractions. So our key thing to remember is keep, change, flip. So in these first couple of examples, it says divide and assume that all expressions are defined. So again, because of this, we do not have to worry about when it's undefined. So when I divide here, we're going to keep our first fraction the same. Change division to multiplication, and flip the second one. Then I'm going to cancel what I can cancel. The 8 here cancels with the 8 here. X to the fourth and x squared, if I subtract them, is going to leave me with x squared up top, and the squared on the bottom is going to cancel. 5/15 reduces to 1/3. Y to the fifth and y squared, the squared on the bottom is going to cancel and leave me with a 3 up top. So now when I multiply straight across, I have x squared, y to the third, and on the bottom, I have the 3. Again, if you couldn't do that, then you could multiply straight across from the beginning. So 5 times 8 would be 40. X to the fourth and y to the fifth. And then on the bottom, you would have 8 times 15, which would give me 120. You have your x squared, y squared. 40/20 reduces to 1/3. 4 minus 2 leaves me with x squared up top. 5 minus 2 leaves me with y to the third up top. So we get the same answer. Let's try another. So we're going to keep the first fraction the same. Change division to multiplication, and flip the second one. And just like what we did yesterday with multiplication, we're going to go through those steps. So your first step to multiply here would be to factor everything. Now I'm not going to go through the steps of factoring because by this point you should be able to factor. If you still cannot factor or do not know where these factors came from, then you need to make arrangements with your teacher for additional help. So x to the fourth minus 9x squared is going to factor to x squared times x plus 3 and x minus 3. X squared minus 4x plus 3 is going to factor to x minus 3 and x minus 1. X squared minus 16 is x plus 4 and x minus 4. X to the fourth plus 2x to the third minus 8x squared is going to factor to x squared times x to the plus 4 and x minus 2. Cancel what's on the top and on the bottom, so we can cancel this x squared with this x squared. We can cancel the x minus 3 with x minus 3. We can cancel x plus 4 with x plus 4. So when we multiply across, we have the x plus 3 times x minus 4 over x minus 1 and x minus 2. And if we FOIL the top back together, we would get x squared minus x minus 12. And FOIL the bottom together, and we would get x squared minus 3x plus 2. Now I want you to pause the video and try example 3 and 4 for yourself. Okay, so for example 3, your final answer should come out to be 3y over x squared. How did we get that? Well, you can cancel, first things first, you keep the first fraction, change division to multiplication, and flip the second fraction. And then 12 over 4 reduces to 3 and a 1. Y squared over y leaves me with a y up top, and the y on the bottom cancels. X squared up top and x to the fourth on the bottom. The x squared on top leaves me with a squared on the bottom, which then when I multiply up top, you just have the 3 and the y, and on the bottom you just have x squared. Or you could have multiplied straight across, and that would have given you 12x squared y squared over 4x to the fourth y. 12 over 4 is 3. 2 minus 4 is negative 2, and since it's a negative, that means it's a square on the bottom. And 2 minus 1 is 1, and it's a positive, so it's up top. For example 4, the first step was to keep the first fraction, change division to multiplication, and flip the second. Then we factored everything. So the first rational expression factors to 2x plus 1 times x minus 4 over x plus 3, x minus 3. The second one, up top for your numerator, you would have 4 times 2x minus 1, x minus 3. And on the bottom, 2x plus 1 and 2x minus 1. So then if we cancel what's up top and on the bottom, the 2x plus 1 here would cancel with the 2x plus 1 here. The x minus 3 here would cancel with the x minus 3 here. And the 2x minus 1 here cancels with the 2x minus 1 here. So up top, you're just left with the 4 and the x minus 4. And then on the bottom, you're left with the x plus 3. So if I distribute the 4 up top, your final answer would be 4x minus 16 over x plus 3. Now, let's try some solving. First thing you're going to do when you solve is to factor everything that you can factor. So if I factor this, that's going to be up top there for your numerator. It's going to become x plus 5 times x minus 5 over x minus 5 equals 14. Then if you notice, x minus 5 here cancels with the x minus 5 here. So really the only thing I have to solve is x plus 5 equals 14. To solve for x, subtract 5, and I get that x equals 9. Now, you have to make sure you check your answer. And the main thing you want to check here is that you do not get 0 as the denominator. So if I plug in 9 here, 9 minus 5 is 4, which is not 0, so this is my answer. If you get 0, then it's not your answer. Or you can start from the beginning and do your domain restriction and say, okay, well, x minus 5 cannot equal 0, so x cannot equal 5. So as long as I don't get x equals 5 here, I know it's going to work. So on this one, if we factor the numerator, that's going to be x plus 5 times x minus 2 over x minus 2 equals 7. So the x minus 2's cancel. So I just have x plus 5 equals 7. Subtract 5 and I get that x is 2. But when I check, 2 minus 2 is 0. Therefore, this is an extraneous solution. And my final answer is that there are no solutions. Pause the video and try examples 7 and 8 for yourself. Okay, so on example 7, if you factor your numerator, that's x plus 4 times x minus 3 over x plus 4. So the x plus 4's cancel. So I just have that x minus 3 equals 7, negative 7. Add 3 to both sides and you get that x equals negative 4. Make sure that you go back and check. So on the bottom here, negative 4 plus 4 is 0. So since I get a 0 here, this is extraneous, which means my answer is no solutions. Example 8, if we factor it, you should have it factored to 2x minus 3 and 2x plus 3 over 2x plus 3. So the 2x plus 3's cancel. And you're left with 2x minus 3 equals 5. Add 3 to both sides, you get 2x equals 8. Divide by 2 and you get x equals 4. So if I go back and I check it, I would have that 2x, which in this case x is 4, plus 3 would give me 8 plus 3, which is 11. So as long as that's not 0, this works, and this is my answer.